Hey everyone, Teacher Chang, and today we're going to go ahead and do some more writing and graphing piecewise functions. So let's go ahead and start off by graphing a piecewise function here. So the first one that we have here is a piecewise function where we have three pieces. So the first one is this negative x plus 4. Our second piece is going to be this 2x over 3 minus 1. And our third piece is going to be this 2. Now, looking over these equations that we have here, I noticed that they're all going to be in slope-intercept form. So all of these are in slope-intercept form, which means y is equal to mx plus b. Now that means we should be able to recognize our slope, that's our m, and our y-intercept, that's our b, just by looking at the equation. So in that first one, we have our y is equal to negative x plus 4. Well, that negative means -1, and that's our slope. So our slope is -1. Our b is our y-intercept, and that's 4. So that's this piece right over here. So I'm going to use that information to draw my straight line. So I'm going to start off by graphing the y-intercept, which is 4 on the y-axis. And then since the slope is -1, that's the same thing as -1 over 1. So that means I'm going to go down 1 because it's negative, and then over 1. So -1 over 1. Now those are my 2 points of my line, and I only need 2 points to draw a straight line, so I'll take my straight edge and I'll draw my line. Now if you're first starting to draw this piecewise function, if you're practicing how to draw these functions, you may want to keep an eraser handy like I have here, and if you're pretty good at looking at your inequalities, you may not need that eraser. But I'm going to draw that entire equation, and the reason why is because, well, we have a piece that we want. We only want this piece right over here when x is less than or equal to 0. So we don't want the entire line. We just want to take the part where x is less than or equal to 0. Well, that means I'm going to go to 0, and I'm going to take a look at the piece when it's less than or equal to it. So, well, equal means that it's on it. So I'm going to include that 0. That means it's a closed circle. And that less than sign, well, less than looks like an arrowhead pointing to the left. That means I want everything to the left of it. So I'm going to go ahead and draw or darken in that line to the left of that point. So I only want this left portion. Now the right portion, I'm going to erase. And that's why I said you can keep that eraser handy. So I'm going to go ahead and erase any piece that I don't want. So remember, it's called a piecewise function because we only want a piece of that line. Okay, so let's take a look at the second one. The second one is 2x over 3. Now that 2 over 3 is your slope. So our slope is 2/3. And the y-intercept is -1. So I'm going to go ahead and graph that point. So I'm going to start off with our y-intercept at -1. And since the slope is 2/3, I'm going to go up 2 and over 3. That's this point over here. And I'll go ahead and take my straight edge and draw my straight line. Now again, I'm going to just go ahead and draw the entire thing for now, and then I'll have my eraser handy because I only want a piece of this line. So we're going to figure out, well, what piece do we want? Well, the piece that we want here is when x is between 0 and 5. We can see that the x value is between these two numbers. So our x is between 0 and 5. So I'm going to take a look at that 0, but notice the inequality with that 0. It's just a less than sign. It's not equal to it, which means it's going to be an open circle. So when I look at my 0, I'm going to look at my graph. When x is 0, I have an open circle right over here. And then we have our 5. Now, if you take a look at the inequality with the 5, we do have that equal sign. And that means it's going to be a closed circle. So I take a look at my 5, the graph, when x is 5, I'm going to put a closed circle. Now remember, x is everything in between it. So I'm going to go ahead and darken in the parts that are in between it. So I'm going to darken in this portion right over here. Now anything else outside of that, I'm going to go ahead and erase. So I'm going to go ahead and take my eraser here, and I'm just going to erase the portion that I don't want. So I don't want anything to the right of it. I don't want anything to the left of it. And I'll go ahead and get rid of these lines that show my slope here. Now remember, we want to make sure that that 0 is an open circle. So I'm going to go ahead and open that up. Make sure we have an open circle here. Okay, so that's that second piece. The third piece is going to be 2, and that's all we have, which means the slope is going to be 0. So we don't have a slope here because there's no x value. So that means the slope is 0. And the y-intercept is at 2. Okay, now anytime I have just a number, that's a big clue saying that we have a horizontal line because the slope is 0. So if the slope is 0, it's going to be flat. It's going to be a horizontal line. So I'm going to go ahead and draw that horizontal line when the y-intercept is 2. So here's my y-intercept at 2. And I'm going to draw that horizontal line here. So that line looks something like this. Now, again, we only want a piece of that line. So the piece that we want is when x is greater than 5. So I take a look at my graph, and I'm going to go to the part where it's greater than 5. Remember, it's not equal to, it's only greater than 5. Since it's not equal to it, it's going to be an open circle. So it's really close to that other one. And then we want to look at that greater than sign. And again, the greater than sign is like an arrow pointing towards the right. So I only want the portion to the right of it. So I want this portion right over here. Now anything to the left of it, I'm going to erase. So I'm going to take my eraser, and I'm just going to erase this portion right over here. Now remember, we want that piece right over here to be an open circle. So I'm going to make that nice and open. Okay, so I'll make that circle a little bit better. There you have it. So there's our graph. So we're done graphing our piecewise function. If you want to get rid of this point right over here, let me go ahead and get rid of that. You can. Otherwise, you can leave it there if you like. Okay, so now we want to go ahead and ask ourselves, is this really a function? Now, what is a function? A function means that for every x value, there is only one y value. So if I take a look and do my vertical line test. My vertical line test means for every x value, it can only cross the graph once. There can only be one y value. So no matter where I draw a vertical line, it can only pass through the graph once. So it passes right over there. We can draw that vertical line anywhere we want. It only goes through the graph once. Okay, now some might argue and say, wait a second. Well, what about the point when x is equal to 0? Well, it looks like it goes through the graph twice. But remember, because we have a closed circle right over here, this is where it really crosses the graph. But the open circle means that it's really close to that point, but it's not quite on that 0. So technically, it only goes through the graph once. All right, so in this particular case, is this a function? Well, yes, it is, because no matter where we draw that line, it is only going to go through our graph once. All right, let's take a look at the next piece over here where we're trying to solve for f of -2, f of 0, and f of 5. Now, we could do this with our graph or just the piecewise function in terms of the equation. So if we take a look at it in terms of the equation, it's asking us, okay, what is f of -2? Well, that means when the x value is -2, well, what is our y value? So all I got to do is take a look at my constraints. So if I take a look at my constraints right over here, that with all these inequalities, I want to see, okay, well, where does the -2 belong to? Does it belong to the first one, the second one, or the third one? Well, -2 is our x value. So if I take a look at the first one, is -2 less than or equal to 0? And yes, it is. Is -2 between 0 and 5? That's not. And is -2 greater than 5? That's not. So it only works for the first one. Since it's going to work for the first one, I'm going to go ahead and recopy that equation. But anytime I see that x, I'm going to replace it with a -2. Okay, so all I did is I substitute. So -2, well, that means +2, and +2 plus 4 is equal to 6. So that's how you do it with the equation. Now, if you want to take a look at it in terms of the graph, well, what I'm going to do is I'm going to look for -2, which is located right over here, and I'm going to look for the point where it crosses the graph. Well, it crosses the graph right over here, and well, take a look at the the y value, and the y value is 6, and that's the same thing that we got. So you can look at it in terms of the graph, or you could do it in terms of the equation. Now, if you're not very good with your graph, if you're not accurate with your lines, you don't draw really great straight lines, well, you may want to do it with the equation. So again, for f of 0, well, that's when x is equal to 0. Okay, so if I take a look at x is equal to 0, again, I'm always going to take a look at the the closed circle over the open circle. So the closed circle will always be the one that we want. Okay, so in this particular case, well, it crosses the graph at 4. Now, we could go ahead and substitute it into our equation as well. So we do know our answer is going to be 4. But let me go ahead and take a look at it in terms of the equation. So when x is equal to 0, is that going to meet the first, second, or the third constraints? Well, it's going to be the first one because x is less than or equal to 0, and we do have a 0. It's not between 0 and 5 because it's not equal to 0 in the second one. So it has to be that first one. So that means negative 0 plus 4. Well, negative 0 is just 0, and 0 plus 4 is 4. Same thing that we got before. All right, we have one more, and we're going to go ahead and take a look at that last one, and it's saying when x is equal to 5, what is our y value? If I take a look at this, remember we're going to the closed circle, which is right over here. Now, if we take a look at that, oh, is that half? I don't know. I'm not 100% sure. It's somewhere in the middle. So what we want to do is this time we want to take a look at our equation here. Remember, we're looking at the closed circle, not the open circle. So I take a look at my constraints. Is 5 less than or equal to 0? No. Is 5 between 0 and 5? And in this case, it's also equal to 5, and that is true. So it's going to be that second constraint here. So let's take a look. We'll substitute in our x value. So it says 2 times x, which is 5, over 3 minus 1. So all we did is we substitute. Well, 2 times 5 is 10, and then we have 10 over 3 minus 1. And, well, 1 is the same thing as 3 over 3. So I'm going to go ahead and rewrite that as a fraction with a common denominator. That way I could go ahead and subtract the 2. 10 minus 3 is 7, so I keep my denominator, so 7/3. So our answer is going to be 7/3, or you could go ahead and write it as a mixed number, and that would be 2 1/3. And if you take a look at our point, well, it is going to be 2 1/3 up. So it's 2 1/3. All right, so that's graphing our piecewise function. Let's go ahead and take a look at it when they give us the piecewise function, and now we need to come up with the equation. So here's our first one, and well, how many pieces do we have? We have 3. So when I go ahead and do this, the easiest way to do it is to look at everything in terms of point-slope form. So if we take a look at it in point-slope form, that's y is equal to m times x minus x1 plus y1. And all I did is from the point-slope form, I moved the y1 over to the right, giving y by itself. So I want everything to look like this format here. Well, I'm going to take a look at the first piece, and we're going to look at that in green here. So this is the piece that I'm going to look at. Oh, I said green, so I'll go ahead and change it to green. So this is the piece that we want. And what I'm going to do is I'm going to come up with the equation first. So I'm going to take a look at a point. It doesn't matter which point you choose. I'm going to just pick a point, and you could pick that endpoint right over here. And that endpoint's at -1, 1. Okay, so that's an x and a y value. So that's my x1 and my y1. Okay, now we need to look at our slope. So I'm going to find another point, and I'm going to take a look at my rise and my run. So up 1 and over 1, which means our slope is 1. So now all I got to do is put it into that equation. I'm just going to substitute. Y is equal to m times x minus x1 plus y1. So I'm going to substitute everything I know. Well, I do know that m is equal to 1. So I'll put, and our x1 is -1, so that means plus 1. And then we have our y1, which is 1. Okay, you could write it in point-slope form, but most of the time, people will go ahead and rewrite it in slope-intercept form. To write it in slope-intercept form, you just distribute. And if you distribute here, we now have 1x plus 1, and then we have that other plus 1 on the outside. And then you just combine your like terms, and in the end, we have our equation y is equal to 1x, or x, plus 2, because 1 plus 1 is 2. So there's our equation. Now, we're going to go ahead and look for our constraint, our inequality. So what we want to do is we're going to look for our endpoints. So if we take a look at our endpoints here, I'm going to go ahead and change the shade of this green here. I'll make it a little bit darker here. So we're going to take a look at this endpoint right over here. Okay, so there's our endpoint. And that endpoint is at -1. Well, that's going to be part of my constraint. And then we can see the other endpoint is an arrow. And it's an arrow going to the left. And remember, left is less. So that means x has to be less than that other endpoint, negative 1. So there's our constraint for that first equation, or that first piece. Let's take a look at the second one. The second one, I'm going to go ahead and do in blue. So that's this piece right over here. So if I go ahead and take a look at this piece right over here, again, I'm going to go ahead and look for a point. It could be any point you want. It could be one of these endpoints, or it could be even that point right in the middle, right over here. And that's going to be at 0, 3. It could be any point you want, as long as it's on the line. So there's my x1 and my y1. And then I'm going to look for a slope. Well, to get from one point to the next, I got to go up 1 and over 1. So the slope is still 1. Okay, so now I'm going to put it into my point slope form. Y is equal to mx, or m times x minus x1 plus y1. And I'm just going to substitute everything in. So our slope is 1, our x1 is 0, and our y1 is 3. So if I go ahead and write it all out, well, now it's just saying 1x, or just x, plus 3, because 1 times 0 is 0. So we have 1x plus 3. There's our equation. Now the constraint. Well, we ask ourselves, well, how many endpoints do we have? Well, we have 2. We have 1 over here and 1 over here. So what are those values, those x values? Well, the x value is at negative 1 on the left, and the y value, the x value on the right is positive 1. So x is between negative 1 and 1. And since they're both open circles, they're just going to be less than, no equal signs. So they're always less than signs. You just need to ask yourself, are they equal to or not? So there's our restriction here, or our constraint. Okay, our last piece is going to be done in purple. So I'm going to go ahead and change this color, and we'll do that in purple here. And that's this one right over here. Let's change this color as well. Okay, so that's the last piece that we're going to take a look at. And again, you can choose any endpoint you want, and we're going to choose this first one right over here, and that's located at 1, 2. That's an x1 and a y1. And then again, I need to figure out our slope, go up 1 and over 1 to get to our next point. Okay, so that means the slope is 1. Okay, again, I'll put it all into my point slope form. Y is equal to m times x minus x1 plus y1. Well, m in this case is 1. x1 is also 1, and y1 is 2. And again, we could go ahead and distribute and change this into slope-intercept form, giving us 1x minus 1, and then we'll bring down that plus 2. Well, we can simplify that by combining the negative 1 and the 2, and that's now going to give us y is equal to x plus 1. All right, so there's our equation. And the constraint, well, let's take a look at our endpoints. Well, we have an endpoint at 1, and we have an arrow on the other side. And that arrow is going to the right, which means it's greater. So that means x has to be greater than, and then we have that 1. Now remember that 1 is a closed circle, so I'm going to include it. So I'm going to make that equal with that 1. Now I'm looking at my inequalities here, and it looks like I did forget that equal sign with that first one. So there is an equal sign with that first one, and the reason why is because it is a closed circle. Okay, so now that I have all of my pieces, I'm going to put them all together and write out my piecewise function, which means I need the equation and the inequality for each one. Okay, so I'm going to take these things over here and put it into an equation. Okay, so I can write it in terms of an equation. If I write it in terms of an equation, I'll write y equals, or you can write it in terms of a function because it does pass the vertical line test, which is my f of x. So if I did f of x, I have 3 pieces. The first one is in green. So we have our equation piece, which is that x plus 2. Remember, f of x is my y. And then we have the constraint of x is less than or equal to 1. So I'm going to put a comma there, and I'm going to put in that constraint of x is less than or equal to negative 1. My second piece is in blue, and the equation is x plus 3. And then I'll put in a comma, and then we'll go ahead and put in the constraints, which is my inequality, and that's when x is between negative 1 and 1. So x is between -1 and 1, and because they're both open circles, they're just less than signs. And then our final one, which we'll go ahead and do in that pinkish color, or that purplish pinkish color, and that's x plus 1 for the equation. We'll put in the comma, and then we'll put in the constraint, or the inequality, x is greater than or equal to 1. And this right here is the equation of our piecewise function. Okay, let's try another one, and each one of these is slightly different. So let's take a look at this one over here. Again, we have 3 pieces, and the first piece we'll go ahead and do in green here. So we can go ahead and start off with this first piece, and you can pick any point you want. And again, I'm going to go ahead and choose this endpoint right over here, and that's at -2, 4. So there's my first point, -2, 4. That's an x1 and a y1. We'll take a look at a slope. So I'm going to pick another point where I could actually read that ordered pair, like this point over here. And I'm going to go ahead and look at my slope going rise over run. So up 3 and over 1. So the slope is 3 over 1. And 3 over 1 is just 3. So again, I'll plug it into my point slope form. So y is equal to m times x minus x1 plus y1. So I'm going to substitute everything I know. I know that my m is 3. My y1 is -2, so that means plus 2. And then we have our 4 as our y1. And again, we could go ahead and simplify this to get our slope-intercept form. So now we got 3x plus 6 plus 4. And then we could go ahead and combine the 6 and the 4. So now we got y is equal to 3x plus 10. So there's the equation. Now the constraint, again, we have one endpoint. I'll go ahead and use a darker green here again. So we have one endpoint on the right, and then we have an arrow on the left. Now that arrow means that it's a less than sign because it's going to the left. So that means x is less than, and then you can put in that equal sign because it is a closed circle, and then we want anything to the left of -2. That endpoint has that -2. Okay, so we're looking for x values. All right, so that's the first piece. The second piece we'll go ahead and do in blue. So that's this one right over here. And this one's a nice one because it's just a horizontal line. So when it's a horizontal line, all I got to do is ask myself, okay, well, where does it cross that y-axis? Well, it crosses the y-axis at 4. So y is equal to 4. And that's the equation. Okay, we're done with the equation. It's a horizontal line. We'll just look for where it crosses the y-axis. All right, so let's take a look at our constraints. And we can see that we have 2 endpoints right over here. Now, this one right over here on the left, I'm going to look at it as an open circle because we already used that endpoint. So if you already used the endpoint, you can't use it again. So I'm going to use that as an open circle, and then I'll go ahead and close it on the other endpoint because I haven't used that yet. So that means x is between these 2 points. Well, it's between at -2, when x is -2 and when x is +2. So x is between -2 and 2. And since I already used the -2, it's just a less than sign. Since I haven't used that +2 yet, I'll go ahead and include it, giving it an equal sign. So there's that constraint. Okay, and then we have our third piece. Our third piece, we'll go ahead and do it in that pinkish purplish color. So that's this piece right over here. And again, we're going to go ahead and pick a point. It doesn't matter which point we choose, but typically we'll choose that endpoint right over here. And that's going to be at 2, 4, so 2, 4. That's an x1 and a y1. And then I'm going to look for my slope. I pick another point that we can read, and we can see that we're going down 3 and over 1. So our slope is -3 over 1, or -3. So again, we'll put it into our point slope form. Y is equal to m times x minus x1 plus y1. We'll just substitute everything we know. Well, we do know that m is -3. We know that x1 is 2. And we know that y1 is 4. So we'll simplify that. We'll distribute the -3, giving us -3x. -3 times -2 is +6. And then we have our +4. And then we'll go ahead and combine our 6 and our 4, giving us y is equal to negative 3x plus 10. So there's the equation piece. Now the constraint, again, we have one endpoint, but again, I'm going to use a darker purple here. So I'll use this one right over here. So we got a darker purple. Now this point was already used in the previous one, so I'm going to look at it as an open circle, and the other endpoint is the arrowhead. So that means it's an arrowhead going to the right, and going to the right means it's greater. So that means x is greater than, I'm not doing equal because we're looking at it as an open circle. And again, we're looking at it as an open circle because that 2 has already been used in the previous piece. So we have x is greater than 2, and that's our inequality. And now I have all 3 pieces. So I'm going to take these 3 things, these 3 pieces, and write out our function, our equation. So we'll start off by writing f of x to show it's a function. You could do y, but I'm going to go ahead and write f of x. Then I'll start off with our first piece in green. So we got 3x plus 10. We'll put in the comma because we do have a constraint. And the constraint is going to be x is less than or equal to negative 2. Okay. Our second piece is just y is equal to 4. So I'm just going to go ahead and write 4. So it's always going to be 4. And we have our comma. And that's when x is between negative 2 and 2. Now, since we already used that negative 2, it's just going to be a less than sign. We haven't used that positive 2, so that's an equal sign with it. And then finally, we have our last one, our last piece, which is negative 3x plus 10. We'll put in the comma, put in the constraint, and the constraint is when x is greater than 2. Okay, so now that we have all 3 pieces, we now have our equation or our function, and well, here's our answer. Okay, we got one more piece, and this is probably the easiest one. If we take a look at this one right over here, we have 3 pieces once again. Now, this particular one is a unique function, and a lot of people call it a step function. Why is it called a step function? Well, look at it. It looks like steps. They look like steps for a staircase. So that's why it's a step function. Now, a step function is where we have all pieces being horizontal lines here. So let's take a look at one piece at a time. And the nice thing about these is that because they're horizontal lines, well, all we need is a number. So the question is, well, what is that number in that first piece? Well, that first piece is when y is equal to 1. Every point on that line is when y is equal to 1. You look for the point where it crosses that y-axis if we were to extend it. So that's our first equation. Y is equal to 1. Well, where is it between? Well, if we take a look at our 2 endpoints, we have a closed circle here, and we have an open circle here. So that's between 0 and 2. So x is between 0 and 2. Since we have a closed circle with a 0, I'm putting equal sign, and well, it's an open circle with that 2. Okay, so there's that first piece here. Okay, the second piece, we can take a look at it in blue. That's right over here. And we're doing the same thing. It's going to be, if we take a look at the y value, well, what is that y value when it crosses that y-axis if we extended it out? Well, that's at 3. So that means y is equal to 3. And again, we take a look at, well, where is it between? So we have a closed circle right here with the 2. And then we have an open circle right here at 4. So that means x is between 2 and 4. It's a closed circle with the 2, open circle with the 4. So I have an equal sign with the 2, but not the 4. And then we have our last piece. If we take a look at that last piece right over here in purple, then I'm going to go ahead and take a look at, well, what is that y value? Well, that y value is going to cross through 5. So that means when y is equal to 5. That's the equation. And that's between, if we take a look at our endpoints, well, the left one is 4. The one on the right is going to be at 6, and that's an open circle. So that means x is between 4 and 6. And because it's a closed circle with the 4, we have the equal sign. And an open circle with a 6, so no equal sign. So these are 3 things. So now if we go ahead and write this all out, well, f of x is now equal to, and then we'll just go ahead and put in each piece. So if we take a look at our first piece, it's going to be 1 And that's only going to happen when x is between 0 and 2. So x is between 0 and 2. It's equal to 0, but not to 2. Okay, now for our second piece, we have 3. And that's only going to happen when x is between 2 and 4. So I'll write that down. X is between 2 and 4. It is equal to 2, but not to 4. And our final piece is going to be 5. And that's only going to happen when x is between 4 and 6. So x is between 4 and 6. It is equal to 4, but not the 6. All right, so there's your equation. Okay, so again, you should be able to take a look at your piecewise function and graph it, evaluate it as well. And you should be able to look at a function that's already drawn out for you, a graph, and then come up with that equation. All right, I hope this helped out some more. If you have any questions, go ahead and leave a comment. Don't forget to like the video and subscribe. And I wish you the best. Good luck, enjoy, and have fun.